Hello. Hello. Session is going to start shortly. Hello.
We are about to start our new lecture of the third day. The lecture 4 will be on the topic of non-thermal techniques for fresh produce, quality and safety. Participants are requested to kindly write down their queries on the notepad, and after the session will be over, you are free to ask any query and questions. Thank you. And I would like to request you to please be active and attentive for the lecture. Thank you.
Okay, good morning and welcome all again. So we start with the next session today is about non-thermal techniques. What is used for fresh produce preservation, maintaining quality as well as safety. So of course in that course we try to cover various aspects related to post-harvest handling, reduce the post-harvest losses. So in non-thermal, probably the name indicates little bit. So we're not using high temperature, okay, not the temperature directly in that one. So that may be our outline. We're starting with the what exactly when we talk about non-thermals, and then we see some common techniques. There are many actually, so we cover some on that one. So when we talk about the food, okay, any fresh produce, it has a lot of components inside the fruits. So of course major is the water whenever we talk about the fruits and vegetable, but at the same time when we say there may be carbohydrates, proteins, some organic components as well as some minerals. So a lot of combinations, okay. So food we see that it's like a complex mixture inside the food, and when we start harvesting the plant fruit from the plant, what will happen? Lot of metabolic changes happening with the food product. So it changes with the respiration, transpiration, and as well as the changes like its enzymatic activity, biosynthesis pathways. So we can say the food start to degrade the quality, okay, and sometimes some changes may be desirable, some are undesirable, like when the changes what we say sometimes ripening and things, but some is coming a disorder for the product which was not expected, or sometimes the quality degradation, some activity from the microorganisms the spoiling the products. That all activities are there actually once we harvest the product. And when we say there are chances to growing the microbes and things, what will happen with the time? It will start it or accelerate the process of deterioration. And what all other things what we all try to deal with, how to stop that or how to inactivate the process, that one. So it may the product will remain the fresh with a good quality, because as always we talk one thing here, what consumer looking nowadays, good quality product, healthy product, and at the same time they look the product have the characteristics like fresh like products. Even sometimes in the market we get the product stored or treated with any other process, but when we eat that one, our idea is supposed to have no changes that may be we easily find that one. So the character is supposed to be fresh like product, because now we are aware that one. And when for the product's life, shelf life supposed to extend it up to certain period, because sometimes it's changes with a lot of things, sometimes for the market size, sometimes the bulk material available in the market, so we'll need to keep for that processing activities. And whenever we look for the processing, when we go for the preservation or some of the value addition of the product, but the spoilage, whatever happening with the food product, that is the one reason we need to stop that one, spoilage. So that's why there are number of preservation techniques, and nowadays when we come here, when we see from the back side 20 to 30 years back what the research coming on, initially coming the thermal, then non-thermal, even the advancement is of non-thermal. So lot of techniques availability as per concern from the industry, concern from the product, we are going for that one. But whenever we're looking for the product to be preserved, and when the characteristics from the product supposed to be fresh product, so of course the industry people, even the processors, they're looking for the techniques like a non-thermal one. So as we say, when we going for the thermal one, there is a chances that the heat treatment due to heat, there is a undesirable changes expected with the product. So now in the food processing, particularly whenever we see the processing side, we converting the product to another product with a different operation involving that one. And in the food preservation side or processing side, of course we're dealing with a number of operations including chemical, mechanical or thermal operations, but with the one target here. What target we say here always? Productivity of the product and the shelf life of the product. That's the two things always we concern actually. If the product we cannot use for the human consumption or the extended shelf life, sometimes people may be not going for this one. And but at the same time there are because what we expect always for the desirable side, but we found here sometimes there are some undesirable effect also happening during the processing side. And during the food processing, one idea here, whatever organism, microorganism responsible for it is supposed to be inactive, and whatever the guidelines, standards or procedure from the market for the product we're supposed to use for this one, so we can keep the product for longer period. Now when we talk here two things in the food preservation or food processing side, thermal and non-thermal in the big categories. When coming from the thermal is a simple one thing we always say, it involves heat. Thermals means it involves heat, actually that's application of heat, and that may be the use for the preservation by inactivating or killing microorganism enzymes which may responsible for spoilage, even the risk for the safety of the product. But what we come here, the factor, it may use sometimes a very high temperature, okay. And probably when we see the examples for that one, we may come across from starting from the pasteurization, blanching, sterilization, baking, because what is happening involved here, that's the high temperature heat treatment, okay. But what, coming with the thermal one, though thermal techniques for some products it's very popular, but it has bring you some undesirable changes. It may be some physiochemical, textural, even organoleptic changes that may be not be expected as a consumer, even the for the product characteristics. So we see that traditionally what the thermal processes were used, like the pasteurization or sterilization. You can see here from the starting, whenever you go to the supermarket, from the milk to your canning material, they use in these treatments. But after in the thermal, there is a advancement come in the thermal treatments. Like for example, we have the radio frequency, ohmic, microwave, okay. So there are some advancement in the thermal techniques, but still just to overcome to what so traditional process we are using in the thermal processing one. So indirectly in the, for example, when you see the pasteurization, blanching or baking, because we're using the high temperature at the same time for the longer period, okay. So just like when we go for the advancement, we want the heating effect, but now at the same time with a rapid process. That's what we expected here. So using the rapid process, so at the same time the process may be rapid, and idea here to degrade it, to reduce the degradation rate from the quality process. And when we're looking for the product characteristics for the consumer side, Nowadays, what we mention here, the consumers looking the product which have desirable quality. Okay, that's the repetition things what we are talking every time, every day, because it's a post-harvest side. We want the product which have the specific quality I expected from particular fruits and vegetable, and at the same time the demand for the high quality, long shelf life, contain whatever nutrient components supposed to be there, and as well as good sensory qualities. Good sensory qualities, the idea here for the consumers, that is the first appealing part, okay, sensory parts, because if the product have the good nutritional, good minerals composition inside, by sensory side you cannot say by the appearance or texture, that is the first appealing, we're not going to buy that one. Okay, so all that things supposed to be there, and it's not for the product side, but it's like a demand from the consumers. That's the awareness increasing by day by day. And then the advanced stage here from the food side, food processing side, they're looking for the technology that may be best for the consumer to meet their demand, their requirement. We come with the non-thermal processing. So one basic difference here, when we say the non-thermal, in the thermal, as we are aware, we are rely on the heat, high temperature. So in non-thermal, the process here that we're not relying in the high temperature. Okay, but some process you may say temperature may be increasing, but in some process you may, but all the processes what we do here, they can use some physical, chemical or biological methods to inactivate pathogens or spoil the microorganism we are responsible for the spoilage. So to maintain product sensory as well as nutrition quality, and at the same time we always use the word here fresh like product. We not say the fresh, okay, we see always what you mention here, the product supposed to be fresh like characteristics. So these processes, when we look here, we consider there may be more energy efficient and more environmental friendly as well, and some examples nowadays which is quite popular, including cold plasma, ozone treatment, UV radiation, high pressure processing, ultrasonic, pulse electric field. So these are some examples what we consider for the non-thermal one. Now you can consider here all the processes we're not directly using or increasing the temperature during their processes. Okay. So again, when we consider here the non-thermal one, because they not destroy or changes quality very less and make the fresh like character, because they are targeting with the non-covalent bond between the foods, with the molecules, okay, between molecules, whereas thermal treatment they have both covalent and non-covalent bond. So in non-thermal techniques, probably we can find here sometimes we have generating plasmas, sometimes irradiation, sometimes even the ozone, that's O3. So we consider this all the non-thermal like a mild heat treatment, okay, mild heat treatment compared to thermal techniques. So when they come with the non-thermal one, some popularity due to some characteristics or some advantages what we get from the non-thermal one, including maximum quality retention, energy efficient, very low chances or no risk for the toxic with the product, processing time also not quite long, so we're not keeping the product for longer period, and here the processes have the high efficiency to inactivate the microorganisms which are responsible for the spoilage. So nowadays you can see in the industry side there is quite trend actually to use that non-thermal processes to keep the product safe and extend the shelf life. So as we consider here, there are number of techniques, number of methods nowadays they are using for this one, and we can see sometimes like a brief introduction for some techniques. Maybe in coming period we may go in the detailing with that all the techniques. So we can check in the brief regarding cold plasma, ozone technology, irradiation, and high pressure one. Okay. So probably cold plasma recent days quite popular techniques in the non-thermal side, which have commonly inactivate the microorganism and pathogen which are responsible for the spoilage of the product. Okay, and mostly you can see that their application is in the industry like a fresh product, processed product, even cut fresh product as well. Okay, so all of the areas the cold plasma nowadays is commonly using, and at the same time the techniques what we do here, it may prevent the loss of all the or sensory characteristics as well as the nutritional one. And so particularly when we talk about the plasma, okay, before I come in this slide here, now we consider the states of matter from the solid, liquid, or gases. When we supplying the energy to the solid, it coming for the liquid, from liquid to gaseous, and the fourth state of matter is our plasma. Fourth state of matter is our plasma here. Okay, so that's what we consider here. But now the plasma, what we consider mention here, plasma is more gaseous than liquid or solid, and now their properties also not similar like gas, liquid, or solid, and that plasma we can use for inactivate the microorganism. So we coming on the step actually how we working this way. So once we generated the plasma from the for the inactivate the microorganism for the product, so in the plasma, first one is our the plasma have the chemical interaction. What is the plasma have some radicals, reactive species, and charged particle which may interact with the cell membrane of the product here, and due to UV it may causes the cell damage to the cell membrane. Okay, and whatever the internal cellular components of the product. But after that one, what will happen once the after the DNA, the main DNA broken down during the recombination of the plasma, but now the microorganisms are not active one, they are inactive, activated there during the process. So this process commonly used as sometimes inactive microorganism, but mostly process you can say like a sanitary process. Okay, just like a cleaning surfaces, cleaning product. Okay, from the surface cleaning one. So that is used mainly for the fruits and vegetable industry, from the surface cleaning, surface sanitation one. And now in the plasma generation, maybe we can go in the detail in the class. There are number of options with the cold plasma generators actually, and even sometimes they use it the vacuum or lower pressure, depends on the product, what product we want to use to inactivate this one. So when there is a number of cold plasma application and techniques which may depends on the what type of product we are using, the surface properties of the product, okay, are you using for the processed one, fresh one, as well as cut slice product. Like for example, when we talk about the one type of plasma where they're working in the low pressure or vacuum, we cannot use that one for the high moisture product, because in the low pressure what will happen, it may be give a undesirable effect like a shrinkage on the product, okay, due to high moisture one. So even though based on that one we can select what type of plasma methods we are supposed to use here. Then what is the initial microbial load, because after this one, because you may be select your intensity, what intensity you need to use, what time you need to keep the product inside the chamber for the inactivation. So that parameters commonly they use and select when they started the process for the cold plasma one. So mostly studies you can see here, because we tried sometimes with the fresh cut product, but the cut product industry still is quite challenging, okay. So just to showing here some products. There are the kiwi actually, they are the sliced kiwi, and they are the control one and the treated one. And the characteristics what we found here, the product what the kiwi slices one after 4 days treated with the cold plasma, still like a fresh like characteristics. Even for the strawberry, now what we come here with the strawberry here, you can see that we try to make the minutes here from 0 to 20, depends on the how much time is the processing time for the cold plasma we are using, and what may be our intensity even. That also affects the quality of the product. Okay. So in the coming sessions, we may check in the cold plasma in the more detailing also. Then another technology in the non-thermal, it is ozone technology, okay. So as we aware, we have oxygen like O2, and ozone means we have one more, okay. It's O3 like a trimatic oxygen molecules. And why it using, because it has very high oxidation reduction potential actually when it's O3. Now the process still very popular nowadays, because I believe around mid 20th century it is ozone come in the market, okay, to preservation the food product. And the basic purpose here of ozone to extend the shelf life of the product, and that is commonly used. Now we have 3 oxygen molecule, O3. Out of that, one O, which is quite unstable, okay, without bond, and when it decomposes, it develops radicals like water, hydrogen, carbon dioxide, and with maybe interact with the interaction here to inactivate the microorganisms. So when we come here in the process, actually we have the O2 and third bond, what we say here, which is the quite weaker one, okay. The big bond like O, which combines with the organic or inorganic molecules from the material or the food material to destroy them through the oxidation process. And then after the process, it may be revert back to making the O3 again, and that's why we consider it's quite environmental friendly process even. So during the production side, that O2 what we mentioned here, to break it in the singlet oxygen, and it becomes from O2 to O3, that's the ozone one. So even the ozone treatment, sometimes it's used as a disinfect the processing one, even that there was sometimes we say they make the disinfected water, ozonized water for the treatment for the products. So they may use in the form of liquid as well as the gaseous one for the all fruits and vegetable category. So when we look for the ozone, the benefit here, actually now you can come here, heat treatment not involved in the process. Okay, heat treatment not involved in the process. And okay, making one thing here, how we getting the ozone, and the ozone process as we effective for the all keeping the products quality, because mostly as the processing not involve any heat treatment or something, including the firmness, weight loss, or even the shelf life, that is the achieved actually. Whatever the study we see with the ozone treatment, that is maintained when we are compared with the other product qualities. And even it will inactivate or reduce the activity of enzymes which may be responsible for the product spoilage. So what will happen here, the process where the product may get soft, actually the process may be reduced or stop here, so preserved for the longer period. And nowadays in the horticulture product, particularly fresh fruits and vegetable, it is also quite popular nowadays. Even India, there are the industries, particularly fruits and vegetable industry, they are applying the ozone treatment for the products. Okay, then we will come with the third one, that's the irradiation technology. Okay, particularly when you say the electromagnetic spectrum, and we talk here the irradiation from this area, from the X-ray, gamma rays that may use for the treating the product. Now you can aware this one, still the technology commonly we not available everywhere, because mostly from the bark from the Mumbai. If we like to use this one, they are the one who is helping here to use the technology. Okay, so we using X-ray, gamma rays for this process. Okay, sorry. So one thing here, when we say the irradiation or radiation, so the product, when we radiate radiation, and that is absorbed by the product. Okay, that's what we get the irradiated food. Okay, and the food irradiation also we consider here our non-thermal process. Okay, and okay, non-thermal process. So mostly the, if you see the irradiation, that may be, it may use for the product to depict the depicted product to sorting separately, control pathogenic microorganism, evidence enhance the bioactive components, and even the sprouting and things for the products, particularly like potato or onions, there may be control with this irradiation process. Now this process commonly used for directly to inactivate or kill the organism, microorganism, insect or parasite, which may looking to the preservation effect. Now, as I mentioned before, that's we are using the radiation like a gamma, X-ray or electron beams for the irradiation process. And for this one, for gamma radiation, we may get from the cobalt 60, okay, which emits the radiation, which may emit the radiation. Then the accelerated electron, what we're using here, that's the electronic beam up to 10 and X-ray energy is supposed to be just 5. Now if you read about irradiation, we can think they give us doses actually irradiation. That is quite important here, because with the safety for the purpose and even for the human consumption, there are some guidelines. We cannot go beyond that much doses for this one. Okay, so they give the doses by the name of radiation absorbed dose. That's we call it a rad. Okay, and what they consider here, one rad is equal to 100 erg per gram. That is absorbed by the product. That is absorbed by the product. And 1 rad is equal to 100 kilo rad, but mostly some microorganisms quite active. They're not inactive with that low doses. Okay, low doses. So this one comes to maximum time. You can say the doses what they use in the kilogram. So 100 rad is equal to 1 gram and 100 kilo rad is equal to 1 kilogram. So whatever you are reading nowadays actually, so the radiation we're using for this one in the kilogram. So they again categorize this one according to what type of doses we are giving to the product. It may be low, medium or high dose. Like low dose up to 1 kilogram, that is mostly used for to prevent the sprouting. Okay, reduce the ripening process and extend the shelf life. Commonly the facility what we have in India here, they have some facility near Mumbai. Okay, and they what the product they commonly use the sprouting. When we look here, whenever they go for the market, like onions, because that has the issue of the sprouting. Even the potato, if we keep for the normal condition, you found a sprouting there. Or the process like a mango, when we selling for the market, the idea here to reduce that ripening process or slow down the ripening process when they going for the exporting. So the low dose up to 1 kilogram, that is commonly used here. Then like 1 to 10, that is like a medium dose, like a pasteurization, that is eliminating or some pathogens, that is foodborne pathogens, are indirectly helping here to reduce the food spoilage. So it has a higher dose and working similar way like a pasteurization. So that's why even that dose they coming like a pasteurization. So you not consider that the heat treatment is going with the like a pasteurization, just a purpose here. And third one is like a sterilization, where they have higher dose. Okay. So they may like a sterilized product, killing microorganisms which are responsible for the spoiling the product and keeping the product for longer period. But now with the irradiation, there are some guidelines with the countries actually. Okay, some countries have the guidelines, so even they may not allow going for the higher doses for the product. So they need to look for the guidelines. But now in the research side, they're looking for that one even going more than 50. So if they working with a higher dose, how the characteristics of the product changes, and even what will be is application side towards the human. Okay, that may be also important one, because at the end whatever fruits and vegetables we are dealing with indirectly going to the human consumption. So if you read this one, even the doses, sometimes you found here some country guideline was quite strict on this one. And mostly in the irradiation, one thing actually we look here to keep the maintain the product. So like we consider it a single DNA product, single molecule product. If the consider irradiation directly attack on that one and that targeting molecule, but in reality is not. Okay, so if the assumption is that is a single molecule to directly attacking this one, but mostly cases they need to consider the second option, that's the indirect one. So they directly what they consider like mostly fruits and vegetables, they are the water. Okay, they are the water, and so they consider here firstly with the redulize the water, and then even the outside the cell attacking the cell. So mostly that's the like assumption for this one, actually not to go with a single. Whenever you come with the irradiation, we never consider that a food product like a single cell component. So this process is still using and quite popular. There is some probably in the research side you not found many studies or many researches going on outside, because for this one I believe in India you need to get the permission from the bar to use this one irradiation. They only one who is helping you to set up your setup and things for this one and do the study. So mostly is they have the setup in near Mumbai, actually I think 3-4 manufacturer, but they like to increase this one because there is a huge potential for the market for the fruits and vegetable, particularly the sprouting, getting the sprouting or dealing the ripening the process. Then we come with the fourth process, that's like a high pressure processing. Sometimes we have the different name, actually high pressure, hydrostatic pressure. Okay, so now this process quite rely on how we applying the pressure. Now the pressure you can consider here 100 to 1000 megapascal. Okay, it's a huge pressure. You compare this one like in our car vehicle we not go more than 30 megapascal. 30, that may be the limit, actually 25 to 30 we keep. Now it go up to 1000. So mostly in the food industry the optimum we consider around 600. Okay, that's the optimum for the most fruits and vegetable processing industry they keep in the high pressure one. So this was a kind of pasteurization process, but not rely on the heat but rely on the pressure. But as we mentioned here, it may increase the temperature, but how? When we go 100 megapascal pressure increasing, so it may increase around 3 degrees Celsius temperature. So even you go up to the 1000, it may be still with your 25-30 degrees Celsius. It's not go more than that one. So it has the some benefits like enhancing the food quality characteristics and maintain this one, because if you see the process here, sometimes there is a desirable changes we can occurring towards the product quality. So when we see in the high pressure one, they basically work in the 3 basic principles, that's isostatic, Lee Chandler, and some microscopic reordering. So in the isostatic, what we consider here, the product what we have, we applying the pressure from the all side, like a uniform pressure applying to the product. So if the product is here and uniform and homogeneous, so every particle we consider here the treating same way. Then second one, with the Lee Chandler principle, what we say, when we applying the pressure, there is a chances what we the changes in the volume of the product. Okay, and as soon as we release the pressure, it may come back to their original one. So one thing probably you may come here, sometimes we can use the product we not keep the directly. Okay, it may be how the some container, it may be how some films, some package, some cans, that way they can use here. Direct product we cannot have the properties, it may change or completely destroyed. And the liquid commonly used in the high pressure processing is water. It's water. And even in high pressure, when we say the microscopic reordering, this one, killing the microorganism, as we keeping the temperature and increasing the pressure, there is a increment of 3 degrees Celsius whenever we increasing by the 100 megapascal pressure. And in this process, when pressure is increasing, it will helping here ordering the molecules. And so the pressure and the temperature in this process, they working in opposite way actually. That's why we call it an antagonistic process, and changes their molecular structure and inactivate the microorganisms. And one thing again you can see here in the package, nowadays we get the package material actually. So when we selecting the package for the high pressure processing, we need to make sure that they have the properties, the change in volume up to 15%. Okay, so if that, we cannot use every type of film, every type of package for the high pressure processing. Mostly you can see in the tin, water, glasses they can use, but the films, what we said, it's supposed to have the properties, it may be reduce its volume by the 50%. When we applying the pressure, we can see our second principle, there is a change in volume of the package itself even. Of course, after releasing the pressure, it may come back to this original shape. So those who working in the packaging side, maybe you can consider this part as well here. Okay. Then when we look for the inactivation, because that's another role whenever we talk about the shelf life, extend the shelf life of the product, means killing the microorganism or inactivate the microorganism. So just to seeing this one, okay, the microorganism active when we applying the pressure. So after this one, what will happen here? The microorganism, as soon as we started applying the pressure up to a certain level, it gets the disturb the membrane due to shear forces generated due to our high pressure, applying the high pressure. So what will happen here? It may disturb into their cellular functions of the product, and then the thermal damage and protein deformation all happening during the process. And yes, the pressure applying from the all sides, so equal and uniform side, and this process will happening. And as soon as we release the pressure, what will happen? It comes to original shape. But the thing what will happen now, the activity of the microbes, activity is not what we say the functional one, so it was stopped or ceased during the process. So they are not active, so that's why we mentioned here they are physiologically inactive, and that's why after the process we can see here this. So it is helping to extend the shelf life of the product. So mostly cases, as we mentioned here, as we go up to 1000 megapascal, so this may be some optimum range, you can see here maximum pressure, but the people are doing the research studies. So what may be optimum condition for different products, if they going for different packaging material, what may be the best suitable pressure. So just to see here the schematic sketch actually when they coming with. So one thing what we see here in the high pressure processing, there is no change in the product shape or size. As soon as we release the pressure, it will come back to its original shape or size. So mostly the high pressure one, when we say the high pressure container, pressure vessel, we have the product, and this may product we have the different packages. Okay, different packages. So number of packaging side we can use here, okay. But as I mentioned, liquid commonly what we use is water for this one, applying the pressure this one. So and we cannot keep the product directly. So the high pressure processing is not only the fruits and vegetable, then you can found is applied towards the meat industry, meat, fish industry, on the processed product as well. Then once we loading the product, applying the means filling with the chamber with the water, and then whatever the or optimum pressure we like to use for this one, like a pressurizing the process, and then we keep for the certain period as we require for the particular product to inactivate the microorganism which is responsible, and then unloading the pressure from and release the product from this one. The process looks, but it's like require high pressure, means the environment need to be checked carefully, because you consider the pressure is huge. Actually, it may be disturb whole building if it's something happening in this site. So it may do is going from 100 to 1000 megapascal, and this is the changes what we're looking for, the how to inactivate microorganism, enzymes, and other agent which is responsible the spoilage. But the target here without increasing the temperature. So in the whole case, actually temperature just increasing, that's the number 100 megapascal, 3 degree higher temperature. So the process come here, and quite popular is the canned and packed product nowadays. Actually, in industry, whenever we see is canned and packed product, these processes are quite popular because it comes with the desirable output, maintain the quality for the longer period. And even so, in the this process, even the other operations we may come consider, like the that may be steps, particularly it may come in the package. So all the pre-processing operation we can do with this one, before this one actually. So the factors when we look here, actually what we're targeting, how for the product, and depends on the time. When we say the loading time, the pressure time, it completely depends on the what type of product we are looking to process with the high pressure processing. And the particularly changes what we look here, that may be desirable one, looking from the texture, structure, particularly for the some meat process, they may found the desirable changes in that product one. And the process, and so the processing time, it may also vary from the product to product. So this type of pasteurizing process, because it has a uniform, because when we look for the product, actually are you dealing with the number of operations. With high pressure one, each components of the part these were equally treated with the high pressure one. So it may have quite benefits, and particularly all the industries even looking for the ready to eat product, ready meals, juices, milk, or dairy industry, fish or meat industry, which may even the raw as well as the processed product, okay, raw as well as processed product, quite popular this process. So this about our processing non-thermal one. So coming sessions, maybe we can go in the technology detail in like ozone or irradiation or cold plasma in detailing on this one. So we stop with this process now here with the non-thermal process one, which may be quite popular and still in industry looking some options which may be more advancement with the specific commodities actually. So now will ask you for the your queries, questions, which may be, yes please.
When the pressure increases,
Yeah.
the temperature will also increase.
Yes.
Yes. So if it is a non-thermal process, hello.
Yeah.
So if it is a non-thermal process, so and if the temperature is increasing, so how it is
No.
becoming a non-thermal process?
Okay. So actually, what we consider here in the process, probably I mentioned one part here, starting like mild heat treatments here. Okay. So now the temperature we can come here. We're not going more than ambient temperature. Like okay, like for example, if you're processing at 0, and every 100 megapascal, your temperature increases by 3 degrees Celsius, not more than 3 degrees Celsius. So even you go for 600, so your temperature less than 20 degrees Celsius. Also, it's like a mild treatment, mild heat treatment.
And another question, when you have told that the about the indirect treatment of the irradiation, like
Yeah.
the UV, because I know that if direct treatment is given, which you have also mentioned that it could damage the DNA.
Yeah.
So, can you elaborate about the indirect treatment?
Like when we consider it, because the components of the just me come on the slides. This one, you have to, that's I same one or
Yes, yes, yes,
yes.
yes. This one.
Okay. So like mostly the food components, what we consider, they have the water molecule, water. Okay. So using the irradiation, what we consider, we are radiolyze the water first with the irradiation, and then considering they are separate actually, and the cell or the DNA we can consider from the outside the water molecule. So it's like we not consider like we are hitting the one cell completely. We are processing okay for the regular for water separately and DNA, then combinedly it may come together.
So, how long the effect of this radiation in water remains?
No, same. It's like because it's process maybe same time actually. It's not a separately.
All right.
Oh,
all right.
means it's not like a separate process we are doing. We are doing the same one.
All right, all right. Thank you.
Even we have the irradiation in the. We can have the detailing station on that one where we may
All
process
right.
this one
Thank you.
completely.
No doubt is here. Okay, so I think we will wind up this
Oh,
session. Okay, so
okay. Thank you. So we'll continue with another one after short break. Okay. Thank you.
okay, thank you. Sir. Okay, so we will wind up this session, and next session we will begin after 10 to 15 minutes. Thank you.
Hello. Hello.
Hello. Now it's okay. Hello. Okay. I think so. We start now? Okay, just 2 minutes. Uh, mm. Okay, welcome again. So, new lecture session that's on ventilated corrugated packaging for posters handling, and that is we try to see the importance of why the structural integrity of the package is quite important, okay, during the posters handling one. So, okay, this outline coming from the starting from the packaging, and then we link here why we use the corrugated package, and finally check here what may be the best optimized package used for the fresh produce. So particularly as you all coming from the background of food and working some students on the packaging itself, we aware why we want to use the packaging. Sometimes protection, preservation, transportation, handling, even for the display. So number of things what we do with the packaging, and nowadays even what are the things we want in the market, like a raw process something, is come with the different types of packaging. So now it's like whatever food material come, we are aligned with the package. We cannot ignore the package now. And this situation is like this one, the packages are number of types, number of materials they are used to handle the package. Maybe it's from the, if you consider whole chain, we have starting from the big boxes, small panels, even the single fruit packaging also used for some fruits and vegetable. So when we see the packaging, it was quite important and plays a very important role to preservation side of the product, preservation of the side of the product. And when it is look for the packaging, because it extend the shelf life, maintain quality, even appealing for the consumers, is the product we can buy it or not buy it. And at the same time, when we concern about product quality, actually maintaining the produce when we keeping inside the package, when you're transporting, handling, idea is the protection. Protection is the one of the important concern here when we talk about the packaging side, because if the package is not good, actually the product get damaged. Indirectly product get damaged, indirectly linked with your economical losses, whatever transport, whatever other process you do better way. So when we look for the post-harvest value chain from starting from the farm, so packaging is involved everywhere. Okay, package is involved everywhere, because in the farm, when you say, sometimes you take the big baskets, big containers, even the gunny bag for transporting one place to another place. Even in the sophisticated way, when in the pack houses, you sorting the fruits and vegetable and making the small packages as per the requirement from the market. So in the fresh produce industry, different sizes, different shapes packaging we are using. And one thing in the protection, what we say here, one concern here is of the mechanical damage, to protect the product from the damaging. Okay, so during transportation, handling, when we see about the mechanical damage, it's important how the package performs and what's its behavior. Okay, behavior is not only for the human, it's for the package as well. At what condition we are using that package? Are we using the transportation side? What may be the temperature, humidity? That also important here. So ultimately, when we look for the packaging, our idea here to minimize the mechanical damage, okay, and improve the performance. Okay, now the whatever we talk here, the things are good or not. Our one thing, one criteria to judge it is the performance, how the it giving the performance. Okay, so even the package is not for packaging also for us the important what is the performance of packaging during this one. So there may be from the whole chain different kind of packages what we deal with. We can discuss this one. Now if you take about the packaging side, is starting from different types: bag, crate, basket, corrugated, one number of type packaging, and even many more. Is just why I show is limited one, even the glasses and other parts. And when we check for the market, what are the packaging common dominant one? In the local market, we can say that they make the local basket from wood, bamboo, or something. But internationally, when we say paper, paper base or plastic base, they are the dominant one. And even in the fresh produce industry, for the fresh produce industry, paper based material or corrugated packaging, which is still demanding or commonly used. There are some reasons for the plastic one for the international market they try to, because their chances are getting more damage of the product. So for local market, we can see here the plastic is commonly used, but for international market, even that percentage is quite higher for the paper based or corrugated packaging. Mostly that's why you say here this was predominantly used for the export market. There are some reasons as well. Plastic become expensive, okay, and for corrugated one there is an opportunity to recycle it after use this one, because plastic they can use for many places, but there is a chances here the cost of transporting and bringing back is not feasible. At the same time, there is an opportunity for the micros. If the product get damaged during transportation, they may be still there. Even your new consignment, it will not work. But only for the local market, you can see it comes. And bamboo basket or wooden, we can see in the local mandis and things, they are quite popular ones. So when we look for the corrugated one, now corrugated packaging, probably I believe you all aware in this case. You are our cartons, box, that's our corrugated package, okay. So it's like a paper based material, and that is the most widely, but as per our requirement we can use it. One thing with this package actually, what we consider, they are light in weight, one thing, but stiff. So even the structure integrity is important for that packages, because we need to keep the fruits and vegetable, and sometimes in the pallets we are arranging up to 8 to 10 layers for the market. So it's supposed to be mechanically or structurally strong, otherwise all your fruits may be got damaged. And it's like little complicated from engineering side, okay, little complicated. That's so what we say here, orthotropic sandwich structure, okay. So what is exactly it means, actually like coming this way, the structure is similar to this one, okay. They have all our cartons, they have liners, two liners, in between they have the fluid. And the challenging one, the mechanical properties for each material is different, your fluids as well as your liners, and as per our requirement we can make that one. And there are even that fluids or liners, they are the different types. A, B, C, D, E category. As per their stiffness, thickness, we can use that one. Even when we looking this one, we may have the double layer or triple layer as per the when we looking for the more shock absorption of the product. So double layer or triple layer for this one. So that's all the basic one for the corrugated carton, and from this one we can make this one. So why is it popular in the market? Because the weight is low. Okay, so when we transporting the product, we consider it may save your money, because your weight side is a low one, and the package we can customize as per our requirement. If you have banana, you have your package. You have apple, you have custard apple, you can make it as per, and it is strong enough to hold the package, easy to print, and even finally after your uses it may go easy to recycle and easy to handle even for the people. And the service and is like a dominant, actually there are the change in that sector, strength of the package, and people are working on that one, how to improve this one. It's a coming period. But the challenge with this package, actually you can come in that idea here, though it's the most dominating in the market, use in the each fruits and vegetable whenever you go for internationally import or export market, even from local. But you may be surprised to know one thing, there is a no guideline from the product side. Okay, product side, if you go in the market, you can see every product have their different packages in terms. If you get the opportunity to see in the market, you can see if it's a banana, the package size, how they make. If it's an apple, for the custard, they change. And there is a no standard guideline for the package. Suppose that's supposed to be side for apple, that's supposed to be banana, that's supposed to be another fruits. So what the manufacturer do, they do how they want, or sometimes maybe the traders or pack house person ask them, okay, we want the packages particularly this size and that size. And though it is more dominant, commonly used for distribution, number of variety. Now you come here again with the environment. When I say the packaging, how they behave in the environment. Now the packaging is for two purposes we're using: transportation, storage. And when the fruits vegetable coming for storage, it's supposed to store at lower temperature. It's supposed to store at lower temperature. That's the when we're looking for long-term storage. And as we mentioned, it's a paper-based material. Paper-based material has the property to absorb moisture. So when it's a lower temperature, we keep at suppose 0 degrees Celsius. Some products 4 degrees Celsius, humidity is more than 90%. It has the property to absorb the moisture. When the paper-based material absorbs the moisture, indirectly it loses its strength. Okay. And then another story with this one, not only for this one, we keeping the fruits and vegetable in the boxes. And fruits are vegetable like a human, they respires, taking oxygen, leaving CO2, heat. If it's accumulated there, then chances to accumulate more there, heat spot, damage, home for microorganism, and whole boxes. So that's another part. So we need cooling, lower temperature cooling, force air cooling. So we pass the cooling air that is passing through the package. Then what we need to do? We need to make the holes to the package. That's what we call the ventilation, and that is the importance of ventilation. And that's why you can see one thing in the market, whatever fruits vegetable in the commercial they using, there is a small holes. Okay, small holes just to escape that respiration heat away from the container and take it out. Even in the transportation side, and this one. Now the challenge here, once our package hygroscopic nature, when we taking some material from that, strength again going to be down, but we need a cooling. That's a challenge here. We need a cooling. We cannot ignore the cooling if you're looking for long-term storage as well as long-term transportation. So okay, we're coming on that point, how to come sort out this one. Then we have that ability for packaging. We want rapid cooling, so we can see more. Now we get, if we want the cooling, rapid cooling, why not we go to maximum vents? But maximum vent means weakening the package. So we aware that one, if we more holes means more ventilation, more air is passing, product get equally effect, but at the same time we are disturbing strength of the package. So how much material? And industry also looking, when they have the holes means they look at less material. That's also one thing. So they need to have the build able to respiration and uniform airflow. That's one thing quite important for whole packages, and that is the purpose. One, we require the mechanical strength. Okay, whenever we talk about the performance of the package, particular corrugated one, what is its mechanical strength and how is this cooling performance? Two criteria always there. Without that one, no use of package for the fresh produce industry. So we required vents, and as I mentioned, there is no rules for the packaging. At the same time, there is no rules for the ventilation. How much percent ventilation is supposed to be there? So there are some studies, they come up to 4 to 20%. But you get that idea here. For plastic, up to 20 is okay, but corrugated, if you go more than 10-11%, the structure try to lose its strength. Okay, and important part, what shape for the vents? It is a circular one, square one. So that also depends actually on what location. So all the factors need to be checked. So they lead to, that's why we mention here one thing here. The package, what we need, that ventilated one, it's supposed to have adequate ventilation, so that may give us uniform cooling. That's one essential criteria. And another one, without losing its mechanical integrity. That's the two things. So the whole size, shape, location, so that is important here, and that how we can design, that is also we can check here. So it may give us sufficient cooling. So in the package, when we look here, pre-cooling probably now I believe everyone aware this one. What is the pre-cooling? As soon as we harvest the product, we try to remove the field heat. So it will help us to extend the shelf life of the product. So as soon as we do the pre-cooling, so before going to the long-term storage, they try to remove, and then we keep the product for our desirable temperature for the longer period. So at the same time, we protection that corrugated boxes from environmental and physical damage, or handling side, whatever damage happening. And so reduced losses are always there, because the packaging is the one concern here to reduce the post-harvest losses. And not only from the like a protection from the condition, but at least the environmental condition also it is helping, because sometimes in the transportation side, weather condition also one thing where we want to protect our product. And sometimes when we say the product, when we're transporting, getting the more damage during the transportation, we have the fluids and layers, so they may adding some more fluids or more layers just to make it product more thicker. So it's like a cushioning material that when we say the adding one fluids rather than one, maybe another one, like it's like working as a cushioning material inside a trap, and working like that air when it's inside the trap is like insulating material, okay, in the air. And when we arranging in the pack houses, that all boxes, they like to make sure actually, if you will if you any opportunity to visit any cold house where they're keeping long term storage, you may found how the ventilation and the cooling they're done actually. So mostly from the holes they try to make that holes and the air may be passed from that one, and so that's why that mechanical properties particularly use here to check this one, and after that recycle things will be happening. Now when we come here, the structural strength, because why we want the structural strength here, important one part is when we absorbing moisture, it may be losing the strength. Another one, when we are arranging the product in the layers or stacking, the bottom one always feeling the more stress, so need to check that one. When they using that much strength, the box is sufficient to hold, even it will not get damage or buckle. Damage is in even the buckling of that package from the bottom side is directly affect the product quality, whatever keeping inside one. So stacking impact and during the even the vibration, because sometimes the packages we use the transportation side as well whenever in the market, so it may be moving here and there, and even the similar cooling condition whenever we look for the import and export market, whatever we have the facility in the cold room, same during the containers. So there is a chances and opportunity to work on that area and how to design the manufacturing. And but now you get one thing clear here, still there is a no guideline, okay, no specific guideline for any organization, just not for the package, not for the ventilation. That's why in the market we can see different type of packages, different types of ventilation for the similar product. Okay, now when they're making this one, the idea here actually when they're making the packaging, that buckle and buckling and things, they like to see here what area it get damaged easily. Is it near where we have the holes, or the middle parts of the package, or the bottom side, or sometimes we have the holding area where they have the openings, but at the same time that is used to hold the package for the labors. So sometimes the idea here, we can increase the strength of the packaging by adding more material, but at the same time it may go towards the cost side. So even what is the important here to get is a more optimization, and this optimization we can do by different ways, by experimental side as well as by simulation side. So as we consider that's a environmental side, there are number of studies how that storage condition, storage environment affecting the package life actually. So when we come here, the package, now today we have the condition like 20 degrees Celsius where we store, then suddenly we keep the package at 4 degrees Celsius, again bringing from back here. Changing in temperature and humidity also drastically reduce the package strength. Probably if you work in the fruits and vegetable, and you can get the idea here, changing the storage condition for fruits and vegetable also link with shelf of the product. Then how much that hygroscopic material, that's a paperboard, absorb the moisture, part one. Then when we arranging in the package, the boxes have sometimes fatigue, creep, and this indirectly linked, because now we're dealing with the package, but at the same time we need to protect the material what is inside the package, because we not directly bother for the simple package, we are bothering what is inside the package. Okay, so because it's for the protection of the fruits and vegetable. And here one study had to come here, the when the humidity is increasing with the normal condition to up to 90%, they found here within a week the strength of the package of 20% reduction. And sometimes, okay, get the idea here, when in the cold storage, sometimes we keep the product more than a month or 2 months or 3 months, even sometimes it goes up to 6 months, 6 months of package. And there are some studies for this one, even with a normal ambient condition. Now you can consider normal condition like a 23 degrees Celsius and 50% RH ambient condition. They found they can keep up to 90 days without disturbing, okay, without disturbing the 40% stack reduction, strength reduction of the package. And the engineering properties on the directional side, when we see the fluid and liners have the different properties, even the x-axis and y-axis, it also have the reduction on this one. So there may be something sometimes come like a liner, sometimes sidewall to protect the package. That's also important here. And then when they're looking for the long term stacking on the pallet one, so they like to make sure that one is supposed to stand up to desired period. So they need to link what is the compression strength of the package even for the given storage condition or transportation condition, and how to improve the performance. But now coming here, two things now what we're dealing here with the package. One is strength and one is cooling performance. Strength and cooling performance for the package. And particularly there are number of experimental side, because now you come near the packaging side and they have number of parameters, so first one they look at the impact one actually when dropping with the boxes completely. Now the package have the ECT, that's the edge, the strength of the edge, okay. Another one, the strength of the whole box, like a compression. And then even that may be happening, and that is quite important to understand during compression, drop, impact or vibration. That's a similar how we deal with the product, single product. Now it may do with some laboratory side testings, okay. One mostly for impact one, we have the drop testing approach. Drop testing approach, particularly whatever we get the package, they go with the testing. So up to certain height, suppose it is our 1 meter or after 10 stacking, mostly for the export container, from the top if it fall down, what side it get damaged easily, and what's the maximum damage intensity, that is all things. Or during vibration, if you're traveling by the road, sometimes by the ship, or sometimes you have different vehicles, so that also checking here if we keep the product directly on the, because if you see the arrangement of the fruits in the package, sometimes we fill the package completely, sometimes we make the layers, the movement of, there may be sometimes chances to get the movement of the package, movement of the fruits inside the package. And then the vibration transparency is important. So just to get here, transparency means how much intensity we are providing actually vibration, and how much absorbed by the package. It's supposed to be minimum, so to reduce the damage. Then for the compression, because that's important, they go for the test like a edge crush test from the edge from the pocket, and using with a different environmental condition. Then for this one, the strength prediction, okay, there are some empirical formulas actually, okay, that is also one of the research area where they go for the different empirical formulas to just to see the relationship between, okay, for how many days we are keeping, what is the size of that, what is the strength will be we can achieve after certain period. So these all formulas we have the empirical one, but this empirical formula we start with the, if you consider here for these two formulas in 1952 and 1963, means they starting the research on that one in that side, but it's just between just to predict the compression strength of the package. That is the one criteria. But nowadays we are coming in the more advanced stage, even using some mathematical approaches or modeling approaches to do that one, because important part now strength, compression strength, how to link with the moisture content of the package, and how to link with even the dynamic environment. Okay. Then the best approach what they come here like a finite element one. Okay, finite element modeling approach that is commonly used now. It's used for the fruits as well, but at the same time with the package. So it may give us the idea how the corrugated package behaving during the giving the dynamic environment. So mostly number of studies they can, and it is coming in this one with we look for the empirical models and things. The finite element is a quite good agreement to check this one. The best part with that finite element with this one, because when in the mass level we need to develop some packages for the industry side, this study is quite helpful to give this one. Now we can see even in the some examples how we can correlate this one. So in the semi-empirical formula there are some issues because not all environmental factors we can consider, because we sometimes we rely on moisture content of package, temperature, relative humidity, and come with BCT. But now you can see here when we talk about the package performance or structural strength, there are number of parameters increasing stacking strength, box compression strength, yeast strength, that is all involved in that one. So in finite element one we have opportunity to use all the factors. So now you can see here this package actually this is used with the finite element simulation. Now in the first one what we see here, the box without any holes, no ventilation at all. So the part little bit yellowish one like the corners. Okay, what it indicates here, this location experience little more stress compared to others, but up to still it's in the range. Then we move to the box actually where we can have the vents, longitudinal vents, and then we can find here the stress distribution is try to increase. The color of that dark gray blue become little light. Okay, but near the holes we found here the stress is going. Okay, but now once we going for the next level, means changing the again the size and shape of that one, how it will improve. So it will give the idea these areas may be the your weaker side of the package. You need to give more attention to that one, or change something, or the maybe change the location of the package with the modeling, because in real world in the package experience it's very difficult, because if you have package, how to find this one buckling happening here or not, and based on that one you may go for the new design side. So mostly they have the same approach. We have pre-processing, we made a design with the knots, coming with the next stage applying the force. Applying force means, like for example we have the package at the bottom one, and when we have the 10 packages over it, so we able to calculate what is the load that bottom package is experiencing one, and that maybe we can use for utilize for our models. So even we have the opportunity here to play with the geometry, play with the location, and then we can test, develop the package based on that one, and then compare the studies. So even the properties with the package, we are changing the fluids, changing the liners. As we mentioned again, there are number of 5 types of fluids. Okay, you can consider there are, and it changes with the strength to strength, A, B, C, D up to E. Even the fluids and liners they are changing, and this finite element one exactly predict us what may be the air strength, what may be the compression strength, and what may be the issues happening near the areas where we are taking the out from the submergals in the holes. Okay, so we have one study actually, so where we can see the package. Actually we use the corrugated package and using the simulated transport, how to do this one. So here in this study we have two different packages with the different sizes and different ventilations, and this package we selected because this package is commonly used for the export market to transport that apple from South Africa to European market. So they have the different size and the holes, and once we have the simulated transport, we using the different frequency. That frequency, how we get this one, you get the idea here when we transporting the product. Okay, so whatever we study do in the lab, real world we can do in the simulation side. When we have the vehicle or truck, when we transporting by the road, why we get the vibration? Because of due to more frequency. So that frequency we can use for the simulation side for particular distance. Suppose we want to travel 100 km, 200 km, 300 km. Based on that one, with duration we can use with the simulation. Then we did here 3 different vibrations applied there for the package, and look here how it is affecting. Now of course what we check here, the bruising and things, so they also look here the bruising here from the yesterday's side, and then we can look for the package transmissibility. That is important, how much frequency applied here and how much absorbed by the package. And then of course for the product quality parameters like bruise area and bruise volume. Then the transmissibility what they found here, with the different packages, because the size and location of the vents are quite different, they give us the different ideas about how much vibration they are absorbing for the packaging one. And the absorptions mean the transmissibility is directly linked with the bruise area now, the damaging. So it's a less number for this one, so we can consider here the package and fruits may be less damage inside. And when again, this is again to see here, when we're using that vibration side, that numbers, when we say when we driving in the rough road or higher frequency side, even that trays get completely damaged or broken. So indirectly it may link with the fruits even. If we consider we transporting 200 km, 300 km with a high frequency, high speed, and fruit get expensive, even we can the cushioning. So now here the opportunity is here, we look for the package as well as the cushioning material what we want to use to protect the fruits and vegetable inside the package. So mostly we can found here the cracks, particularly not the top layer, the bottom side one get a crack completely, because the bottom side, that the place the fruits experience more stress on the boxes. Then another one, there was a study for they used again the 2 different types of packages, corrugated packages for the banana. Is a study from the Australian market. Now in this one, this type of package we use here to transport banana, like a single piece and double piece package. And then what they do here is a simulation. Now you can consider this the picture of this one. This is the palette what we saying here. It's like a real world experimentation here. They have the stacking the banana with the number of layers up to 8 to 10, and similar experiment rather than single box. Now the whole pallets they are using the vibration. Okay, and the experiment, like, because this one like a trailer, and their idea was that one they transport more than 1,000 kilometer, because it's like a country was, it's like a coast of Australia they make that one, and just to simulate how we are transporting from that 1,000 kilometer that product. Then it's like a once we get that this one, and then they go here to check here the properties, like what is the mechanical damage directly, and link with the what is the vibration transmissibility for the package, how we link that one, if the package is absorbing vibration and how it links with the damage of the product. And though after this one, now we may come here that one, though with using properly and bottom side rubbing that layer, and these parts is directly our bruise. Okay, what we talk about a bruise, the packaging get higher transmissibility value indirectly linked with the product quality what we keeping inside the package. Even and this one visible because 1000 kilometer, of course it taking that more than 1 day, so after 24 hours is visible completely, and that is linked with your the again the physiological changes, increasing transpiration, water loss and things. And then they call here mechanical damage index, and they coming the idea here, the particularly open package is getting more damage, just to compare with the package, different packages, different designs, because you have that opportunity now. You can design your package and see for this product how is suitable, making the single package, multi-package, you have the different ventilation side. Then another one like where we can see the rather vibration. What about the compression? If you use the compression study for this one, now we have the package we keeping in the common environment, and that's the compression testing machine actually, where we have the package just to check now how when we're applying the force on this one, this load commonly come with the what the whole pallet we can arrange actually, that may be the force supposed to be applied there, and how the package is behaving on that force. And the package, when we're applying the force, now you can see here the middle part where the we have the holes, and here tend to be under buckling. Inside it moves inside, okay, and similar to this side. So we have the experimentals here, and we set up into the finite element here again. Now you can see here the under buckling here in the middle part, and even the damage what we predicted here is similar like the experimental side. Even this part is the weakening part here, where they're looking for the new design of the package to consider the factor here. The middle part maybe need to be strong limit, or otherwise they need to change the location of the vents. Even the top layer, but top layer still is a permissible one. But when you see the in the red side, another one, this package is little buckling, under buckling, still it comes, but compared to another packages has less effect. So when we're talking about advocating about that modeling approach and link with the experimental side, it has the opportunity for the researcher in this area to come with the unique or the design for particular product, considering the all factors to design the package one. Okay, and now we talk about the here the finite element one, but again the cooling performance. Okay, the cooling performance, it's supposed to link with our cooling studies. So when that is also we can do with the simulation side. One is with the finite element, when we say about the mechanical strength and structural strength of the package. Computational fluid dynamics, CFD, that is the another tool we can use to check the cooling performance. So what will it gives us? It will gives us how the, suppose we have the vents here, when the air is passing, cool air is passing, how is moving inside completely stack, whole stack, it is passing completely, or the product getting the restriction. Because when we, I think there was a study one question, if we making the cushioning material, it may be restricting the airflow or not. So by simulation we able to see, okay, whatever the air we are going is coming out from the opposite side or not. So because that air is supposed to trap inside, and at the same time each fruits inside the package get uniform cooling. If not that one happening, you consider, okay, if the long term scenario, if your product you are transporting for 2 weeks, 3 weeks, and one product never get a cooling effect, now high respiration linked with the physiological changes and damaging. Even other products are good, but one product not, it may in the 3 week you are damage your whole box. So mostly times for the optimization that things, we need to look to three things in the detailing one. One is your structural, like a finite element, plus computational fluid dynamics, and not to forget one thing, plus that is your quality characteristics of the product. At the end, what we're looking, that's the product what we're keeping here, it maintain the quality throughout the whole journey. So based on this one, we optimize some, and probably those working in the packaging side, even I urge for this one, try to explore this area, because this area still not many research in this particular one. This is a quite a good opportunity, as industries sometimes they approach, they want the packaging but come with a more systematic way. Okay, so there are some studies and some papers, if you like to go in the more detail, more about the how to structure design, how to that vents, where to locate, even the finite element, how we are applying for the particularly when design the package, this may become in this way. So what location, up to what the optimized size, where this may give the guideline for this one, or what may be structural integrity, or even how we are implementing finite element for the handling the packaging as well as the fruits combined together. So this about the ventilated packaging, but importantly you get one idea here why we want to vents, because foods are vegetable like us, they respires. Okay, so we stop with this one here. Okay, thank you. So we expect some queries, questions.
Any queries? Any query, any doubt? Please feel free to ask.
Good afternoon, sir. Sir, which material there is using for that ventilated corrugated paperboard?
It's like our paper based corrugated, like if you see the cartons actually. So it's
Cartons.
that same material actually we use.
Okay. Sir, then means you are saying about it will absorb more moisture.
Yes.
So how long we can transport in these paper boards? Like
Some studies is goes up to the 90 days in the storage side. Okay, if we not changing, like suppose we keep the package today is 4 degrees Celsius, tomorrow 23 degrees Celsius again, so it will not withstand for longer period. But if we maintain, we keep in the same condition at 0 degrees Celsius, 4 degrees Celsius, it may go up to 90 days, even more than that. And but there is a stacking, we can see the loss up to 50% of the strength. But once we take it out, maybe you cannot utilize the package again.
okay.
But in the if you using for temperature fluctuation, so even the time may be less, it will not go for more period, longer period.
Okay. Sir, it is suitable for our horticultural produce, like
Yes,
fruits and vegetables
fruits
and
and
all.
the fruits which respires, okay,
That is nice.
any kind of fruits and vegetable we can do that one.
Okay, sir. Thank you, sir.
Okay.
Any other question?
Good afternoon, sir. My question is, does this ventilated corrugated packaging affect the labeling or branding?
No, not really.
No?
Because it's like a outer side actually. We're not compromising strength, and the labeling and come if not during the manufacturing process actually. Mostly the labels and designing graphics during manufacturing of the package. So
Okay.
it will not affect particularly the performance of the package.
Okay. Sir, one more question. Does it affect the structural integrity of the product? If
No,
yes, how?
Particularly, if we see here, we are planning to protect the fruits and vegetables inside the package. So integrity of the package, if disturb, indirectly it disturb the fruits and vegetables.
Okay. Thank you, sir.
So,
Any other question?
okay, okay. Oh, thank you again. Thank you.
So with this, we are winding up our day 3. Participants are requested to be here after the lunch at 2:30 p.m. And we will be having 3 practical sessions today. And you are requested to be there in the food process engineering department. Thank you.
Good afternoon, everyone. Today we will see three types of equipments. One is oil expeller, rice bran polishers, and next one is the spray drying. All these are the mean for the post harvest technology. This is the screw press oil expeller. It is the lab scale type, prototype, pilot type. The here I just want to say that what is the means equipment details. This is the motor, and it is the inlet air to heat the airs by the through the motors, and this is the screw. Here you can see, I can show you here. You can see inside, see this is the screw, and outside it's a barrel type. Then after that it's the oil discharge tubes. After that outside the oil cake discharge, and here the outlet air will be there. The main process is the compression and heating of the means and rotating of the screw, which does the friction of the oils, and it is squeeze the mustard seeds to discharge the oil. Whatever now first we provides, or we just in the hopper we just pour the our mustard seeds. Okay, then it will go to the screw press, around the screw press. Then the screw press is rotating by wheel, by the mechanical process we are getting. By the this the application, by the rotation the frictions will generate. Due to the friction and also the inlet air, for the inlet air application, the walls or the cell walls, it will destructed, or it is somehow loosened, which can be used for the oil inside the cells. Okay, so we are taking now mustard seeds. You can also take mustard, groundnuts, flaxseed, all these oil seeds types which contains around the greater than 40 to 50% of seeds in their biomass. It can use for the oil extraction. It is the efficiency is 70 to 95% of the efficiency. Advantage is very less time you can get very high amount of oils, and it is very crude oil. You have to purify if you are using for the home purposes, all these things. And the next thing is less power consumption. It's very handy, you can use at a home, all these things. But the disadvantages is after the over applications, overdoing, the heat generation will be high, which can also reduce the health benefits of the oil you are targeting. Okay, means suppose you are doing the mustard oil, after overheating, means after overdoing it, after 2 or 3 hours of applications, it also reduces the nutraceutical applications of the mustard oils. Now we will see the how the mustard seeds means we will pour the mustard seeds, and how the oil can be ejected. Pause. We just pour and we will do the experiment.
And another part is that the main part is the expelling screw, like it's like a thread. So you can see it here. Okay, this is the expelling screw, and this is the barrel, operation barrel. Okay, and this is the seed hopper, and during performing the operation the thread will rotate in which direction? Clockwise direction. And when it became clogged, that means if you apply some more material according to the beyond the capacity of the machine, because it will perform the operation maximum 4 kg per hour, because it is the cold pressing machine. Okay, some other machines are hot press machines, is the cold pressing oil expelling machine, and it will take maximum 4 kg per hour. Okay, and the capacity of the machine is 0.5 HP, 400 watt. We have to apply our material. Okay, so now before performing the operation, put your material after with a proper measurement, so its weight is 500. No issues. Okay.
Been already produced, already expelled some amount, but and these are the oil cakes. We can also use the oil cake twice thrice to extract the all amounts of oil inside the seeds. Okay, it will take the continuous process. So I'm not going that much. I'm just telling. And this oil is a crude oil. It cannot be consumed as such. It can be purified. First separation, then purification, then you will consumed as the mustard oil you are in your home, जो भी है. And also, and this process you have already seen, na? Any doubt you can tell. Any doubt you can ask all these questions. And this is the machine, it is already running. While it is going as this is the cleanup, means reverse screw rotation, so that it will means while cleaning purposes, na, after the oil are already been ejected, then while cleaning all the seed cakes whoever remained, it was to be cleaned. And this seed cakes also has been a very good amount of other nutrients properties. It can be used as a feed. You have a cattle feed may be used hota hai ye. Other than it has also contained used as bioactive compounds, also starch, because cells has some compound of starch fibers. You can also use that. Do not throw it. Means our this is now the recent decades are producing from the waste, food from the waste. And nowadays some industries are also applying some effective techniques or effective innovations to use all these seed cakes to some cattle feed or some carbon dots, all these things. And in packaging material also it can be used for the food materials. It can be good packaging materials. Okay. Any see the demonstration of rice polisher. Rice polisher is to separate the rice bran from the wholesale, yeah, whole grain. Yeah, this is the black rice, you can see black rice, and the bran is color is black. Okay, if you have want to means polishing the rice and get the white rice, pura whole white rice what you are consuming today, means every day also, then you have to you have to run in the rice polisher to get yeah, separates the rice brans. And the equipments, it is the motor, you can see that this motor is responsible for the rotating of the this inside that abrasive roller is there. Abrasive roller is the means it is having the rough surface roller. You can see here the screen is there, you can see outer screen is there. Okay, inside that abrasive roller is there. Okay, the main mechanism in this rice polisher is the abrasion and friction. Means see, this is the outer surface, okay, the screen, and inside it the abrasive roller is there. When we apply the rice inside it, rice with bran, then it will go inside the rollers and it will circulate when we start the motor, and it is get friction between the screen, I mean outside screen, with the abrasive roller. Then the outer surface of the rice, which is bran, it is get separated. Okay, then here you can see there are two portions. I can show you. This is the head rice portion where the rice is collected, and these two portions is for the bran collections. When we run the equipment, okay, heavier particle is what? Bran or rice? Rice, obviously. When you stop the process, then the lighter particle, whatever the circulation, means bran, it is get down into the adjacent sides, means these sides, and the heavier particle is get into the or collected in this. Okay, we can start the process then. This is the black rice we have already done once to get the separate the brans now, but there are some even also the bran is there, so we'll do again. Okay, we'll pour some. Okay, now so here is the monitor one is there. If you want to use how much time, means say it is, I have set already 2 seconds, and it is maximum up to 1 minute or 2 minutes, because if you will do maximum over the 1 minute or 2 minutes, the rice will be broken more. So the less time we'll run, but in a multiple times we get the maximum head rice. You know, head rice, broken rice, all 2/3 of the rice, means if it is the fully grain, okay, this is a fully grain, and if the 2/3 of the rice is being saved, that is called as the head rice, and 1/3 of the rice is called as the broken rice. So in this equipment, head rice proportion is 40 to 60%. So in minimum time you will run the multiple minimum minute, you can run the multiple times, you will gain about 60% of head rice. Otherwise broken rice will be more. Okay, we'll start the process. I just do the 2 seconds of time, how much bran will be collected, we'll see. And this is the portion where if we remove this, all the rices or all the head rices will come. Okay, can see from there also, their brands are there. Outside the cell, you can see there are black color brands are there. Here also. Here see, we have to do another more time so that the black portion will be removed or bran also removed. You can see there. It is black rice. Now optimum time में हो जाता है, but black rice में थोड़ा portion रहेगा because it's a whole black rice and bran निकलने में time लगता है, and you cannot remove all the brands from there, otherwise the broken rice will be formed. You can see the brands from there. It is for the paddy removal. The cells, outer cells होता है, ये उसमें remove होता है. Okay, ये disc type rice seller है, and the disc is rotate as a, this is the same concept, abrasion and friction conditions, but they will roll into the anti-clockwise. Okay, here we can get rice with the brands, but without cells. Okay, if we run the another more time, then okay, come forward. ये black rice, I don't know the varieties because I am not working on that. You can see the bran. Black portions are the bran. Okay. You can also calculate mathematically how much bran percentage removed, how much head rice has been collected, how much broken rice has been collected. You can also mathematically say the weight of the bran collected divided by the weight of total rice we have put inside the cell, polyser into 100. Then you can calculate the percentage of the bran separations or the efficiency of the machine. You can see simultaneously it will collect the brands. Okay. See, if you do now, the broken rice will be formed. Don't recommend to remove the brands also because it is high amount of anthocyanins, and these brands we are wasting it, and nowadays these brands are used for the anthocyanin extraction, and it is using as a health benefits and nutraceuticals. So don't remove it and soak it and use it as you have also friends as Assamese people, they have used as a whole black rice. They don't yeah, but okay. What is this equipment? No, spray dryer. Okay. So what is the purpose of spray dryer? Why we are using this? Any ideas? Yeah. Means it is a spray dryer. It is a innovative equipments which are used in the industries for for developing the powders from the liquid products, slurries, juice, all milk, any other samples. Okay, in leisure times also. Here you can see it is a lab scale a spray dryer. Okay, this is the lab scale. Here you can see this is the air compressor. Okay, this is the air compressor where we inlet the air into the system. Okay, and here is this is the heating metal where we heat the air. Inlet air will be heated here, and this is the chamber, heating chamber or the spray drying chamber. When you see inside it, you can visualize the nozzle insides, which is called as the atomizer. Okay, then this is the separator, cyclone separator. Okay, there are one cyclone separator, in some cases two cyclone separators are there also. Then this is the filter. Okay, and after this is the back side, it is the aspirator. Okay, I'll tell you all the working principles. This is the aspirator and this is the back filter. Okay, one by one we'll go the component wise. this is the what I told, air compressor. Means for the spray drying we need means the main mechanism is the means atomization of the liquid droplets into tiny particles or tiny powders, okay, by heating, okay. So we need heat, but in a air compression medium, okay. And this is the heat medium where we heat the airs, and also though if the liquids are not in the liquid, that's why I told her to preheat, so that the time of the spray drying will be minimum, okay. If the liquid is in the above the 50 or 60 degree, so that to spray to drying the means the liquid product will be the less time, okay. And here it has a pump of the liquid feed, okay. Feed pump इधर है, नहीं दिखाई दे रहा है, तो इधर means this is for the means if we the feed means liquid products, any type of samples, okay. The it will goes to the this section and it will go through the nozzle, okay. Nozzle के through यहाँ पे देखो कि बड़ा बड़ा holes होगा, this is a mean for the air passing, okay. So this is the co-current type of spray dryers. Here we can spray though through the nozzle the milk. The example is milk. I am telling the milk. Okay, will means passes through. No, the milk is passes through the nozzle by drop. It is very tiny droplets, and at the same time the air heating air, it has the temperature of 120 to 160 degrees centigrade. Okay, this air is being also ejected through the same time, okay. Then the heating medium, the heat transfer will be occur, heat and mass transfer. Then the droplets which has the moisture, it get evaporated fastly, then it forms the powders, tiny powders are very particles, small size powders. Then it will go, then the here comes the aspirator has the mechanism of the creating negative pressure, means creating vacuum, okay. Here as the pressure, okay, it produces negative pressure that sucks the this powder and air as well, okay. Then powder and air will go to the cyclone separator. Cyclone separator is the mechanism of the cyclone separator is a centrifugal force. It will rotate as the centrifuge, higher particle will be stays downside and the lighter particle will goes through the air, goes through the pipe. Higher particle air in between air and the droplets, the higher particle is air and powders, the higher particle is the powders. The powder will be collected through this, and the air with tiny powders, another tiny powders will go through the filter bags. Here also the air also get filtered, and the dust material also separated. Then it goes to the back filter. Here the clean air will be produced outside, and whatever the another retented dust will be there, it will be stayed outside. Got it? Then next is the mechanism inside the this I have already told. One is the heat and mass transfer, then evaporations in the moisture evaporation, fast evaporation, then is the separation, okay. The means there are different types of spray dryers there, co-current spray dryer, counter current spray dryer, mixed types of spray dryer. It means हो गया ना, हाँ ठीक है, okay. It means it depends on the air flow and the liquid flow of the inside the chamber. So if that is in a different direction, that will be the counter current, and it is in the same direction, it will be the co-current, and it is in the both direction, then it is the mixed flow spray dryer, okay. And then we will see the how the it will works. इनलेट एयर में कितना हीट होता है 120 degree, but it is for the heat sensitive materials. I am telling for the enzymes, peptides, proteins, all these things. But it is not heat sensitive material, then what should be the temperature? Temperature it goes up to 300 degrees centigrade, okay. But there should be an outlet temperature. This is the inlet temperature, And another is a outlet temperature. Outlet temperature, any guesses what is the temperature range? It should be in 30 to 80 degrees centigrades. If it is heat sensitive material, then it is 30 to 40 degrees centigrades. Then it is normal material like milk, juice, all these things, then it should be 50 to 80 and 50 to 60. Then it is above non-heat sensitive like starch and fibers, all this is not a heat sensitive material, then it is for 80 degrees centigrades. Okay, now we'll see